Here we go. Apologies for the delay. My computer nearly exploded when we started streaming, so I'm gonna be keeping an eye on it while we go.
If you hear any high-pitched noises,
Yeah,
that's
that's the fan flying out of the back of my laptop.
So welcome once again to 3DQ's live stream. I'm Steph Sharp, CEO.
Mateo Pekic, co-founder and chief of innovation.
And this week we are talking to Professor Eric Woolridge. We're happy to welcome him back. He's from the Additive Manufacturing Center of Excellence at SCC in Kentucky. And he works a lot with all types of additive manufacturing, from plastics to metals. And he's been testing Quinly, designed a nice little torture test part for us, which we'll be looking at tonight. And we'll be talking about some of the parts and some of their experience with that. So before we jump in, just want to welcome all the newcomers this week. Hopefully we won't have a computer complete meltdown here. But if you have any questions through the process, this is an interactive format. And just so people know, on Discord, you can come in on Discord into our community channel, or you can come in through Twitch TV on their chat on Twitch TV. So yeah, so make sure to post your questions, and we'll see where we can go from here. And we'll see if your computer lasts, Mateo.
Yeah,
I'm not 100% sure.
We just need one hour before it explodes.
Yeah. It's not a happy computer right now.
I don't know what's going on with it. Yeah.
It's not even that old. Okay, so
why don't we join Eric?
Let's get Eric on, because he's been waiting patiently behind the scenes here.
Hey, Eric.
Hey.
Sorry that took a bit of time. Mateo's computer has suddenly decided to
kick the bucket, basically.
Kick the bucket. Yeah, we don't know what's going on. Anyway, so I was just saying to the folks that this is an interactive session. We're really looking for lots of comments and questions and participation tonight. We got all kinds of stuff we can talk about. And I think we'll probably have some pretty interesting technical discussions around, obviously, automation, the Quinly kit, and 3D printing in general. So maybe the way to start off, Eric, is just to maybe you can tell folks what your background is and what you do at AMCO, and yeah, just give people some idea on that side.
So my name is Eric Woolridge, and I'm professor of the Additive Manufacturing program for the community college system within the state of Kentucky. We're referred to it as Somerset Community College, AMCOE, for the Additive Manufacturing Center of Excellence. And at the base level of what we do, our job is to get 3D printing and additive manufacturing skills into the workforce as quickly as possible. And we do that oftentimes through low-cost additive manufacturing equipment, which we refer to as LCAM. And the reason we choose to go that route versus expensive stuff is simply because we can build the skill set in faster. And what we tell folks is this, that 3D printing success is not about the 3D printer, it's about the mentality. So our overall goal is to look at the grassroots applications of the technology and then go up from there, whether it be in a company, in a tool and die operation, whether it be a person who has a side business on Etsy. This is the technology that is changing the world, and everything from supply chain support to advanced products. But we just want more people to understand it and grow with it. So when the opportunity to take a look at this technology came along, it was an ideal scenario for us, because automation in additive manufacturing is truly the next step. So yeah, very excited to be here. Appreciate the opportunity as always. And I look forward to questions and comments and some good conversation tonight.
Yeah, absolutely. And we're so happy you could come back and join us, Eric. We've been chatting lots over the last couple of weeks as you guys have been putting your kit together and putting it through its paces. And we're looking forward to hearing a bit of a recap. First of all, I guess we've kind of heard as you've been going along, but maybe to give everybody who's watching some idea of who put the system together on your side. Where is it? Where is it running? What was your first test part? That kind of thing.
Well, honestly, one of the folks who's actually watching tonight is Justin Flugum, who is the person who actually put the kit together the first time. But he set it up as soon as we got it and did some fine tuning, and then we set it up in the lab after that to start the overall bigger production. And that's kind of where I took over in terms of going for the automation, the part design, what we were after, and getting it dialed in and scaling up from one simple part to the next part. So Justin would be the person to talk about that personal experience. My experience on this is the designing the parts and testing out the build applications for the automation. So what I started with when I got it is going from one cube to another cube and then doing 3 cubes and then spanning it out, really trying to dial in the adhesion level. Once we got the cubes dialed in and those were printing and being knocked off the plate afterwards, well, being go through the process of cooling down and being released from the plate and restarting. Once that was in, then we switched to the more complex shapes, the donuts that I think you have some pictures of and those files for. And we go for those because those are the lattice structure designs, the more complex things. And then moved up from one of those to doing 2 of those, and then do those in batch production. And then the next step was to move up to what we consider the true power of additive manufacturing, and that's its ability to complement generative design. And generative design is where all design is going. It's artificial intelligence basically removing the need for the designer by saying the designer provides the extent of what is absolutely necessary for the part to work. Maybe it's a connection point, maybe it's a platform, whatever the case may be, and generative fills in the blanks based on the loads and that kind of thing. And so that type of design, that type of 3D printing application is what's truly important at this stage, because those are the shapes, that's where the technology is advancing. So that's why we moved to doing that next in the test, to see if it could handle the complex shapes of generative design. And so we moved up, we did 1, we did 2, and then and those were printing just fine. Then we moved up into reinforcing them more by increasing the wall shell thickness in the inside of the structure, which typically increases residual thermal stress during printing because there's just more solid material to pull against. And that's when we started getting some successful tortures, if you will, and starting to get some warping, and then we're starting to try to adjust from that. So that's kind of my experience with it. I think we've been at 2 weeks now in the process, maybe 3. And we've been running that thing like crazy and working on getting that pristine dial-in application of exact first layer squish, speed, temperature, and response to material. And once we get that dialed in just a little bit more, then we're going to switch over to metal.
Yeah, I'm excited for that. But you do bring up a hugely important point, I think, in terms of dialing in materials, since and we've spoken about this before, but just the amount of variation that comes in 3D printing materials, especially with FDM right now, is pretty, I'd say borderline ridiculous. You could get, yeah, you could get two of the same color and same material from the same supplier, but 6 months apart, and they've spent that time improving their formulation, but there's so many variables that you've set up in your slicer for the old formulation that you end up getting a weird artifacting that can even have to do with the material. I mean, that was something that was most surprising to me, that same brand, same color, same material, and you can end up with different outcomes.
Yeah.
Yeah.
We've definitely had
I think that's good. I think we're going to see that from here on out, simply because exotic materials and new material applications and new recipes are going to be the name of the game. I mean, we just saw a new guy who's actually we've got hops out there, we've got beer filaments, we have some guy doing something ground beans or like soybean filament, and it's just going to continue to happen. But these materials may have some ideal properties that might be useful for someone. So the material battle of settings and dialing it in and the differences from one batch to the other is going to be a thing that we'll be seeing for a long time.
Yeah, like there seems to be sort of an arms race. I think earlier this decade it was all about improving the hardware as the patents started becoming released on printer hardware and hot end hardware. And then more recently there's been a ton of development in terms of software too, but I think right now kind of where we're seeing the most innovation, and as a result which can cause the most variation over time, is there's practically a new material coming out every week or two, like some crazy new thing specially made for 3D printing, for FDM printing.
And it makes for some really attractive parts, both aesthetically and then also functionally. There's some really nice mechanical properties starting to appear, but it really causes challenges the first few times you're trying to print it. That's
Yeah,
that's for sure. And I think it would be interesting to have a little bit of a discussion around even what we're finding with the two PLAs that we're using right now, because we're living this right now. And anybody from your team who's on, if you want to throw some comments into the chat,
yeah,
that would be great. Because I think it's been surprising for all of us, some of the
it's
stuff
been
we
quite
found. So
interesting.
maybe just talk about the two PLAs that we're using and
Yeah,
go from there.
let me pull up the photos. Maybe, yeah, I guess to give some context, you were printing parts well and fine with this material until we moved on to that generative bracket, where it printed fine with 3 walls and 4 walls, but then with 5 walls you couldn't get it to stick. And we were trying to replicate it on our side, but of course we have a different brand of black PLA, and for us it seemed to work fine. And then
we were very happy with our part, actually. It's like, looks really nice. We didn't have to do a lot of finishing or anything.
Yeah, but then we found the G code was pretty much totally non-transferable to yours, even though it should be within the same domain of settings.
Yeah, the transfer back, and when I saw you all actually just knocking that part off, no problem, 4 or 5 shells, no problem. So I was really curious when that G code came back and running it, that even the first layer, and I was actually incredibly surprised on how fast your first layer was being produced. Generally, we run our first layers very, very slow, and to increase the adhesion potential. So when I saw that, I was like, this is a really interesting scenario between the two of us. And then, of course, we went back and forth on making adjustments on your G-code side and keeping our hardware constant, just to see if there was a G-code setting that was really doing it. So, where I was doing 75C for build temp or bed temp, you were doing 60C, and you had no problems like that. And then we start switching mine down to 60C, and then we're not getting, it kind of looks like it's sticking to start off with, but then, it's coming loose before the first layer's on. So it's not an issue of like retraction or anything of that nature, because it never gets to that point. And I think at the end of the day, the reason yours is working is that in this particular scenario or material, you just have the adhesion is better on the front, on that first layer, which is keeping your part from curling off, unlike mine is. So we've got, there's some discrepancy there. Could be material. Very much could be. Could be some other setting we haven't hit yet too.
And we are using, just for people who are watching, we are using different setups.
Yeah.
Because we use a different, well, maybe you can go through what some of our upgrades are, and I know you upgrade differently, because it's not like we're both using standard enders, right? We both upgraded our enders, so.
Yeah, like ours are running a V6, E3D V6 hot end, which does change the printing temperatures a bit. And then we've got an inductive probe. I know you guys have one as well, but it's a bit of a different model.
Yeah. Justin can feel free to throw in the chat box what that model is, because he put that one on.
Yeah.
But the extruder system, the platform itself, is the micro Swiss that we're using for ours.
Yeah, you've also got direct drive too, right?
Correct. And it's a strong direct drive too. The micro Swiss setup really pushes the filament down. I mean, it does not have a problem there.
Yeah, I think part of what's been curious on our side is like it's not like we only print with this black PLA, and like we printed in other colors, so to see and generally like even different colors from different brands are within the same realm. So I mean, we've been going back and forth on this for a couple days now, so it's been kind of interesting to discover like it's not with our temperatures are completely different for we're using Pryline black PLA, which we really like, and the adhesion on that stuff has been perfectly fine, but then switching over those settings to your guys' material just fully doesn't work. So I think as we go on through this, we've been talking about like coming up with a way of either trying to come up with some standard tests to prove out the to set up the best adhesion parameters for a new material, based on what we've learned here, because yeah, there are some settings that are just non-transferable, it seems.
Yeah.
Yeah, I agree with that. I think that's going to be the way to go.
I have a question for you, Eric, that I haven't actually asked you before, through this. Sorry?
I said no prep. I haven't had prep for the question.
I'm just letting people know there's no setup here. No, but I'm
Yeah.
interested to know, because I know that you guys had set your temperature at 75 for this material. Is that what you always printed at?
To be fair, yeah, I usually crank up the bed temp. We're generally, and I like heat when it comes down to it. When we run our sidewinders and other things and other products, we generally run, or I generally run 80, sometimes 90. Again, it's always to fight that residual thermal stress. And some of the evidence of the effect of that is that after the parts, because we've all had that situation where, you know, you print and you've done so much to get that adhesion that it's almost impossible to get a part off a normal bed. And what we found is if you can get more heat to it the first layer and let it print, and then as that cool down starts to happen when the part's done, you can hear it pop loose. I mean, they just slide right off in many cases, or at least there's much less effort. So, and also, you know, it just helps with the residual thermal stress and that warping effect too. So we generally run hotter on the bed temps as much as possible. So it's not uncommon for me to be hitting 80 or 90 on my platforms.
That's pretty interesting, because I'm almost of the exact opposite opinion. Like I like to run the bed as cold as it can be while it still sticks. Part of it might have been just starting out with ABS, but minimizing the thermal gradient across the part, I found there's a balance though. There's definitely a balance, because on the one hand, your bed heats your part, and if the bed is hot enough, it can keep the entire part warm and prevent it from warping. And if the part isn't super tall. But on the other hand, you are creating a pretty big thermal gradient, especially in terms of an open system where your bottom layers will stay expanded and later layers will cool at different rates depending how far from the bed they are. This is kind of my internal theory of why I found that PLA in with the PLAs I've used warped at really high temperatures. It was definitely like in an open system, you have a really high thermal gradient the higher you pump up the bed. So I've been trying to personally, when I print, I like to avoid doing overly hot temperatures. But that's not to say like we have done PLAs at like 70 and 75. There are certain ones that just needed that to stick.
Absolutely, no question.
Yeah.
So it's
And
already
your
a pretty
geometry, the
interesting
fact is, your
difference.
geometry affects it too. And
Definitely.
so this is why this learning curve is so important for all of us in the field in general to really understand the complexity of additive. And if you want to get quality work out of it, all the thought that needs to go into it. Now, once you get dialed in, you can produce to your heart's content. But the mindset that a person can just go buy a printer and download something from Thingiverse and actually, and they say they know 3D printing is a farce. There's a lot of science to this, and there's a lot of opportunity for real intellectual growth with the process.
Yeah, I agree. It's interesting because one of our folks has just gotten his first 3D printer. Really doesn't know. This is one of our software people. Doesn't really know anything about 3D printing, and he's printed off a ton of stuff, right? And like a bunch of different colors, and he just went crazy. All Thingiverse, things. So I think it's interesting that on the one hand, it's just a fun thing to have, like an Ender's not that expensive, Quinly's not that expensive. It's a fun thing to play around with. But then you can make real parts and you can be doing functional pumps and mounts and enclosures and all that type of thing. We're just showing a picture of his collection. That was after in his first 10 days of 3D printing. This is what he created.
Yeah, it's like basically everything from the front page of
Thingiverse. Yeah, it could be the new front page of Thingiverse, I think. And but I think that's a really interesting lot of technology that is a serious industrial strength technology. But it's also fun for people to use. And I think that's going to change the future of manufacturing, because we're no longer going to say, oh, well, the only way to produce this is some, big center that's, in some foreign place where they have to do millions of these things. Manufacturing is going to become almost like craft, where it's manufactured, but, locally, right? Or distributed, where people say, hey, let's all manufacture the same thing, but in the different places we live in the world, right? It's got really interesting potential.
Yeah, we are setting out to undo what Henry Ford did.
Yeah, exactly. Not a fixed assembly, but just like print whatever you want.
Anywhere.
Yeah.
Not all in one place. Yeah. Yeah. And efficiently.
Yeah, you only got one choice with the Ford models. You had black or black. Now we say there's the possibility that we can get you whatever shade unique to you, which our world is all about unique. And there's a technology that says, you know what, I can do that without increasing the cost. If you know what you're doing, you can actually make those industrial grade and level parts for super complex with no increasing cost whatsoever. And that's powerful. And that's something we've never, ever in our history as humans and manufacturing things had the option for. Custom always costs more up until this point.
Yeah, exactly. There's really no concept of mass customization beyond like other things like regular printing, right? You can do that with digital printing. This is just basically digital printing, but in 3D instead of 2. Like as soon as everyone got an inkjet printer at their house, they could print whatever they want, or they could go to one of many local printing facilities to print off whatever they like. You can go to Staples or FedEx or whatever to print your stuff.
Well, and it's interesting because I was around for the genesis of desktop printing. And the premise with desktop printing was that, publishers and print houses, they were gone. Like there would be no more printing presses, and, nobody was going to need to go to printers anymore. But the interesting thing that we quickly found out is that, in fact, a lot of people can't design or layout, and 42 fonts on a page is not a good look. And and the quality of your graphics matters.
Yeah.
And it really shifted the conversation in the print industry towards, quality versus quantity with people, kind of DIY. So I think we're gonna, we are already seeing it in 3D printing. Um, you got a huge variation. You've got a lot of people who believe that FDM style printing can't be an industrial technology because they see Thingiverse and they go, well, it's not serious. It's like an easy bake, right? It's like it's not
If
real
only it were
manufacturing.
that easy.
Oh, you're right about that. And it goes back to that mentality too that we always say. It's not about the printer; it's about the mentality. And once you harness that, you can take advantage of not only all the new materials that are coming out every week, but all the new printers that are coming out every few months. And you can just keep going with that mentality. I mean, let's face it, we theoretically can start beaming files back and forth from across the world to be produced at any location.
Well, that's what we've been doing the last couple of days, isn't it?
That's exactly what we've done the last couple of days. That's exactly right.
So, one of the other interesting things that I think as we've been going, back and forth through this whole process is the conversations it generates around the different parameters in 3D printing. And I know we are getting some folks. I know we have some folks on tonight who are pretty experienced with 3D printing. I'd just be interested, Eric, kind of what ahas you've had through the process in terms of, picking your settings and laying down the profiles and stuff.
One thing that's very right off the bat, aside from like your quick and easy temperature differences, that when I ran your all's G code versus mine, I saw a very different squish effect. And the squish, of course, is just like how tight we're getting that first layer to embed into the plate itself. Actually, the first time we ran it, and I sent you the picture back, you said that's actually a little bit too thick. Where I was, this is a good thing. My extruder nozzle up more, which made it stringier at the very least. And then of course there was the speed. So that was one of the things that I noticed right off that really spoke to me in terms of, okay, this first layer squish, the width of it and everything, I think that's a parameter that is something that we can eventually start to measure unit per unit. And I say that, I mean, like, it can actually be quantified in a way to say, okay, you're setting up your system on whatever printer you have put together, whatever Frankenstein you've done in that case. But the build plate that you all have with your kit, that's going to be what matters at the end of the day more than anything else. So I think the look of that first layer and quantifying that as a tutorial and a guide or maybe an image to overlay, I think that's where we start to making the customer experience, as fluid and easy as possible. And settings, of course, we know that's going to affect or be affected by our extrusion multiplier. It's going to be affected by our first layer nozzle height. Theoretically, it's going to be affected by the speed that we're going, and of course the temperature. So we're dealing with 4 or 5 variables right there. But that first layer look, if we can quantify and measure it and replicate it from like one system to the next, I think that's a huge win in terms of setup.
Yeah, and I mean it's 4 or 5 variables, but I think of that as a good thing because doing a normal print is like 20 variables, so 4 or 5
True.
is already a bit of a lightens lightens the work a little bit in terms of developing a method. But you're absolutely right, and something that I found interesting was for your black PLA, you found that you had to really squish that first layer in, whereas with
Yep.
the one that we're using, I actually found that a first layer like too squished actually makes the automation that makes the adhesion worse with the vapor bed. So again, it's going back to this material difference. I'm gonna put a video up that the viewers can see of some tests I was running last night. It's like a pull test from our previous stream, and I done the first layer normally. It was actually like 0.2 and printed at 0.2. I think the only change I really made to it was a 10% increase of the extrusion multiplier, and I was able to get off of that black PLA. I hit a peak of 9 kilos of force on this tiny part. So I'm just gonna play that in the background while we talk. But um, it it does demonstrate like the insane importance of just making sure that those settings are dialed in. And I think you're right in how um, I think it'll be easier to dial in a first layer than it is to dial in an entire part. So I do think there could probably be a pretty robust methodology. And I mean, that's why we sent the kit to you 3 weeks earlier, is so that we could work on it together and see where it was deficient and where we can improve that.
Yeah, and that's also why I ordered more filament to match what you all have, so we can check it from our side and see if it is material issue that's there, or if it's some other system we haven't thought of yet.
Yeah, well, if maybe it's some of the hardware upgrades just come up with, I
Yeah.
don't know. It's going to be really interesting to see.
I mean, we could even end up learning something about our bed QC process, because every bed we ship out, we do test it with the black Pryline. We ensure there's sufficient adhesion when it's hot, and then also when it's cold, that the part release is complete. But maybe we learn something that type of testing has to either be extended, or the type of model we're testing has to be changed in some way. Yeah, depending on how we see this.
That's the great thing about getting product out to a whole bunch of people, because they use it completely differently, and so you know you have sort of have aha moments all the way along, like, oh yeah, well, you know, that's a good, why don't we try that? I know we've got a question
Yeah,
here
I
if you
just
want to.
saw this.
Yeah.
So Raco5 asked, can the Pi kit for the Quinly be set up with a Raspberry Pi camera? I think with the latest software update, there actually might be enough memory on the 2 gig Pi to run a camera. So you could try it out. Or what I would recommend to be safe is just buy a 4 gig Pi, and the bill of materials is on the site, so you can probably pick those up from Amazon if you want. And really, flashing the Pi kit is for people who just want to get up and running right away. So flashing the firmware on, or flashing Quinly onto the Pi on your own is well documented in case you want to run that. But that does actually bring an interesting point in terms of kind of automation and quality control. So you've been printing with this for quite a while now, and quality control in general is a pretty big topic in 3D printing. How have you found that your desktop machine, like in terms of consistency, yeah,
What's
like,
your repeatability? What's your or defect rate?
yeah,
Well, here's the crazy news about it. Once we have it dialed in, we don't really have defects. Once the repeatability has been constant. Like, we ran a bunch of those cubes, and once we got the settings right, those cubes aren't any different from any others. We didn't have any fails. Once we had the donuts figured out, we didn't have any fails. In fact, that's what I was using to backtrack from the issues we were having with the TV bracket, is that I would just switch over and fire the cubes back up, printed just fine. Switch over and fire up the donuts, just fine. In fact, actually, that's what's running right now is, actually, no, we got donuts done, and then I switched back to one of my earlier TV brackets with like the 2 or 3 shells, and it was printing just fine when I left. So the repeatability is really, really good. And that's, in honest truth, that's what we're seeing a lot of at Additive right now. Comparatively with injection and molding, there's all kinds of things that go wrong when you're trying to force, hot molten fluid into an open chamber, and you have to get everything right, get the air bubbles out, and all this stuff. In this case, you only have to deal with an extrusion of a tiny little layer, and it's typically easy to get that right. We saw this during our COVID production, thousands of face shields, and you have maintenance issues and printers going down, but when you have it dialed in, the product just comes out over and over and over. So repeatability is excellent right now. We haven't had any mistakes or fails once we got the original design dialed in.
Yeah, it's a pretty interesting idea. Like you had mentioned this to me a couple weeks back when we talked, and thinking about it, I always had this idea that 3D printing, because of all the slicing variables, was way more complicated. But when you think about it, hardware wise, your melt chamber is always the same.
And it's small.
It's small, and it's a single cylinder.
Yeah, it's not a lot of variation. I mean, going back to the easy bake kind of thing, one of the because I ended up, I had an easy bake as a kid, and then I actually baked cakes. And one of the things that was a surprise to me, because I'd started with easy bake, is my cakes didn't turn out as consistently with a real oven as with the little easy bake, because the easy bake, your material's in a little tiny
It's
pan.
always the same dish.
It's
too.
the same dish. It's a little tiny pan. It's in a little tiny chamber, and it's a 60-watt light bulb.
Yeah.
It's like almost as consistent as you can get. And then you go out and you're using different ovens. There's gas, there's electric. You're using different pans. There's like glass, ceramic, metal, and your cakes keep coming out all different.
That's it. Yeah, that's a really interesting analogy. Like
Yeah.
even the
Great
batter.
analogy.
Sorry, Eric. Go ahead.
I said that's a great analogy. That really is.
Because I'm thinking even the batter that comes with the kit is like optimized to be.
Yeah.
It's almost like plastics made for 3D printing. You have batter that's made for easy bake. That's pretty. It's an interesting parallel.
I might steal that analogy for my next paper that I publish. You just in case you see that out there, I am totally going to rip that one off. That's an excellent analogy.
You just have to cite me on it, Eric. That's all.
Yeah. That's pretty cool.
The
Yeah.
easy bake scenario.
Yeah.
Easy bake paradox.
Where I was kind of going with it was, you've got this really small melt chamber, and like thermal things are very difficult to predict, but in 3D printing, because it's such a simple chamber, it's much more predictable. And where in injection molding, you still have all the variables that come with molten plastic that you have with 3D printing, but like looking more into it, those variability issues are actually solved in the hardware, in how you design your mold, where you're doing sprue placements, how the plastic flows through the mold. Whereas with 3D printing, because your nozzle and melt chamber is consistent between any object, you're offloading all that variability into the software.
True.
Which is why I think slicing is so complicated, compared to, I mean, injection molding software is no easy task either, but in 3D printing, there's hundreds of these variables that I think are being offloaded from the actual tooling that comes with traditional manufacturing.
And Eric, I'd interested to hear your thoughts about that, because you guys must deal with the slicing issue all the time.
We do. And another thing, I'll go into that injection molding. I mean, let's face it, the technology is very mature at this point in time. It's been around forever. And yet we still have injection molding failure rates that are pretty significant, because there's just so many things you cannot control. And with the easy bake printer, as we say, you can control that. So we actually work, since we teach, we have to work with whatever software is readily available too. So we'll do research on one level with slicing, and then we'll do your intro and your teaching on another level of slicing, because we don't expect the students to have to go out and buy slicing software. So we'll try out what actually is working well at the time for the students. We do Cura. We're probably taking a look at Prusa's system now, since it keeps being updated as well. For the research side or the higher end work that we do, we generally run with Simplify. And it's exactly what you say it is. I mean, you can take the same printer and use two different slicers and get two different qualities of parts. And it's in the magic of it's in the logic of the slicing that makes a huge difference. And the variation is crazy. Of course, we started off with Repetier, and and the other one, I think one or two others. But now the slicing is getting smarter, and I think eventually the next step will be more artificial intelligence adding into the slicing, where the software will figure out the slicing settings that need to be based on the performance of the part, the same way we're going with generative. Now, what drives that is will have to be more software companies integrating additive in their platform overall. So, that might be something that we see out of Fusion before too long, since they're already going in the CAM side, is that their slicer gets smarter and smarter and smarter. And so that we won't even have to really think about the slicing settings either. We just say, this part's going to be exposed to this range of temperature. Here's the forces on this part. Our generative design has already given us the solution for that. Now the slicer is going to say, well, I'm going to optimize your wall thicknesses in certain areas, and I'm going to optimize your speeds in certain layers, and I'm going to change the thermal properties per layer based on what my scenario is. And here comes this machine learned slicer that can just take a part and make it just incredible. And we sat back and barely even designed, and we barely even sliced, and out came a part.
Yeah, at some point you'll just jack into the printer through your brain and be like, I want something that kind of looks like this, make it work for me.
Yeah.
Read my mind.
Yeah.
Read my mind. Every woman's dream.
And that's what we've been doing as of late. So the bracket that you all have out there, for example, I mean, the objective of that design is for me to design as little as possible. Just basically say I've got a rectangle at the end with two holes in it and a cylinder at the other end, and they're sized to fit over a pipe here and two bolts here, and it does the rest. And so we're actually really wanting to find out how little we can contribute to the situation and how little we need to show. We've literally gone from like really complex designs to now all I'm drawing is like a cylinder and a rectangle, and I'm stopping.
And two holes.
And it takes from there.
Yeah.
Two holes, boom.
Yeah.
It's like, here's the most complex thing you've ever seen. And I'm like, that's awesome.
It's so cool.
Yeah, it really is. And it's hard to show in black on the camera, but it's really quite. Sorry?
So that is true. I should probably send you like a screen capture of the model itself to see it. Where it's
I think we have
I actually think I might have.
I think we do have a screen capture. That's a good point, Eric. I'm pretty sure
Let me pull it up.
I think we have one that you sent early on when you were saying I'm designing a torture part for you.
Oh yeah,
for Quinly.
Yeah. Here we go.
Exactly.
Actually, I've already taken the design that we're testing right now, and I've increased it another 50 millimeters because we realized the camera wasn't hanging out far enough. So I just went back into the model and just moved another 50, and then told it to regenerate. And it gave me a slightly different shape and creation, but it's ready to go now too.
Yeah, it's really interesting. I think the other interesting thing, and I know you guys have touched on it a couple of times, but when you talk about speed, it's not just how fast the nozzle is moving around laying down the plastic. You really, speed matters in terms of the whole print process. Retraction, the more you have to retract and the more often you have to retract, obviously the slower your overall print is, even if your nozzle is running around as fast as it can go. And we did some optimization, quite a bit of optimization here. And within about a year's time frame, we went from doing, we said 8 to 10 grams an hour of.
I think it was like 5 to 8 or
5
something.
to 8, yeah. Well, and we were pushing it up to 10, sort of.
Yeah, on some parts.
To over 55 grams an hour.
Yeah.
So suddenly your print times have dropped, down to a tenth of what they were when we started. What kind of work are you doing on that type of thing, Erica? Where are you seeing that going with automation?
Speed's everything. I guess you have to build your business up to get that volume out there. And so that's a little bit of a catch-22 for a lot of the folks that we work with at the grassroots level. We want them to grow their business, and we love it when they have to keep buying more. So generally speaking, what folks will do, especially since we're using LCAM as our example, if volume increases, instead of them worrying about dialing in and getting it faster, they're more likely just to go buy another printer, which is generally fine because the cost of that is easily justified in how many more orders they're getting. With maturity, though, And as we see these things scale up more and more, obviously faster is better. And faster also helps in terms of that cold layer effect. If you get back around and that layer is still warm or warmer than it would be if you let it cool down, that's a better bond. I mean,
Yeah.
we know for a fact that your layer-to-layer bond is affected by your thermal differential between the two. So the faster it gets back around is great. So from a production standpoint, they'll probably not worry too much about it. They'll just get another machine and increase capacity. But for performance, speed's better.
Yeah, I think again, what we spoke to a bunch of these Etsy store owners, and I think they're pretty much a prime example of what you're discussing, where over the course of about a year and a half, most of them went from their first printer to having between 8 and 20 machines. And they have exactly that mentality that you're talking about, where if you're running into demand issues, you just go out and buy another printer. But I think
Mm-hmm.
what will have to happen at some point with 3D printing is a shift in thinking towards throughput. So that part of that is speed, part of that is operator availability. It's interesting hearing these stories. Some of them, they have 12 machines. They've got more demand than they can handle, but the machines are only running with 50 to 75% uptime.
Not even. They think it's
In
75.
some cases, yeah, in some cases it could be even lower. But the point being that if you could solve that uptime issue, one, that's essentially doubling the amount of printers you have or print hours per day. And then two, if you can increase the speed on top of that, then again that goes into your throughput. So I think like I don't know if we're seeing it yet, but I think there definitely has to be, especially as 3D printing becomes more and more involved in actual end use part production. I think there does have to be a shift in thinking from get more printers to how do I improve my throughput to get the most out of the printers I have. Because often throughput improvements are also much less expensive than purchasing and maintaining more machines.
And that's an excellent point, too, because I think as we approach this comparison, more people start to look at additive for production versus injection molding. It's always been this whole battle of speed. And, we're going to point out, hey, look at your failure rate in injection molding. Well, that's going to take it a little bit off the pedestal to begin with. And then look how fast your additive's getting, and as we move and more people consider the additive approach, then we're just going to want faster machines. We're just going to want to produce more and more and more and more. And like you say, less machines. Now, to be perfectly honest, if the machines are actually just solely automated and they're just knocking off parts super, super fast, and we can also point out the fact that the maintenance issue is not necessarily huge with some of these, especially when you get them upgraded and dialed in really well.
Yeah.
So I think there's going to be people aren't going to be worried about the speed too much until they start saying, hey, I'm starting to really compete with injection molding here, get this thing faster. And I like that. I like that a whole lot. And I honestly think it's going to happen quick because the maturity of the technology for additive is just way faster than any of us actually ever anticipated. And it's way faster than any other manufacturing approach we've ever had in the past. So it's growing and improving way beyond our normal curves.
Yeah, I think one of the interesting things with the whole idea of just adding printers, and my background, Eric, I think I've told you before, is finance, and the from a financial perspective, the adding more printers doesn't make sense because that means people, every time you add a printer, if the first one isn't running 24/7, if it's running 5/16, which a lot of them are, right, 5 days a week on a couple of shifts, then what you're doing is you're compounding your inefficiencies, right? So rather than buying another machine, buying automation makes sense to keep the first machine running as much as you can before putting a second one in. But that's kind of logical, and it's very traditional industry look at, you got a capital cost, you want to get as much through as you can. But one of the things that surprised me is one of the limitations people were running into is electricity. So
Yeah,
in
that's
a,
a funny one.
in their house, right, they can only run so many printers, and now you're at the limit of a domestic residential.
But then you ask, why are they running them in their house?
Well, that's a
Right?
different question.
Because they have to be there to
And
maintain the printers.
but that's it. It becomes a circular issue, right? Because they have to be there to remove the parts. And so they don't want to drive to the office at 1 o'clock in the morning or on Saturdays. So they have it in their house, but their house only has, a residential load of electricity. So again, if you're automating what you have, you're not increasing that draw of electricity at one time. Because the problem is about staggering your printers, because honestly, your printers don't consume much except when they're heating up, right? And so you could do elaborate schedules of staggering all your printers, and you could probably put a lot more into a residential, but these guys are not thinking that way, because they're just thinking, oh, just add a printer, just add another printer, and then, oh, now I've run out of room for printers, now I have to move it all off site, now I have to drive back and forth to my office, or that kind of thing. So I think, to your point, Eric, about mindset shift, right? It's on so many different planes. There's so many different parts of the mindset that have to change, and where people could have huge efficiency increases.
Oh, yeah. Well, speaking as an individual that slept in his office for 8 weeks during COVID, to actually do that reset in the middle of the night, I would have wished we had this system back then in March, and then my life would have been a lot easier. And it's an easy sell for me to say, okay, the less I have to have contact with this printer, the more efficiency my time, theoretically, the more money I make if you account for the labor associated with doing that work. So it just makes sense to take what is working and automate it, and then consider moving that automation up faster. And if you can't do that anymore, then you go buy another printer.
Yeah.
But it just makes complete sense from so many levels that we want these machines to run by themselves. I mean, that's what everyone wants. Companies would love it if their injection molders could just run by themselves, but they can't. It takes people being there. It's the technology that we don't necessarily have to have that for that case.
Now is possible to run by itself. And the interesting thing we found in terms of that whole speed issue, once we've got the automation, now we focus on slicing. Because I think I was telling you in the first round, Eric, that when we did the face shields, originally they were taking us 75 minutes to print. And with some design changes, and because we had automation, we were able to tweak and tweak and tweak and tweak with the slicing. We got it down to 35 minutes a shield. And so that's a huge, in an industrial setting, that's a crazy, huge, decrease in time. And then we also brought the material down, and we had a better product at the end. Didn't have the same weak points. It fit better. It had a customized part number actually printed right into it. So for traceability reasons, for medical, that was huge. And that was all because we were pumping out hundreds, and we could keep, changing it on the fly, right? Again, you're not stuck with the whole injection molding process. So you can keep optimizing, and you start looking at other parts of the process. It's not about, tweaking the machine, it's tweaking the software. It's even back to design, right? Not just slicing, but even back to the design. So
Which is honestly very funny, because less than probably 2 months ago, I gave a presentation on what we learned from COVID, and I was actually saying the opposite, because we didn't have automation. And I was saying, okay, just because there is a possible improvement of a design, don't do it, because you got to keep your production workflow going with all these systems that you've dialed in and everything. Now with this system where it's totally automated, you interject a new design application, the chances of it changing and requiring a whole lot of problems is much less, especially with your adhesion system as it is. So you actually have a solution that we didn't even have to allow you to efficiently optimize on the fly, because all the other print farm systems, you can't do it efficiently. You have to actually make sure you have it dialed in across the entire board, and you have the repeatability, where yours repeatability is extremely high right off the bat, no matter what the part is. And I think that's really powerful.
Yeah, it's been very interesting, obviously for us watching how things change and how it shifts from an industrial perspective. I think COVID really shifted our perception of our technology and where it's going. I'm sure it did. I'm sure it shifted everybody's, really perception of 3D printing.
Yeah.
And I think it's been quite an interesting journey. And I'm just looking at the time, and I think we're already. I can't believe it's been an hour.
Yeah.
Thank you so much, Eric, for joining us again. And I know we're going to be talking lots more on Discord. And for those people who are watching, you can jump into our community Discord anytime. But yeah, it's really been a great conversation. I am, I'm a newbie on the technical side. I know the finance and business stuff, but I always find these technical discussions really interesting because they give me ahas for, where the financial and economic benefits are on the 3D printing. So really love having you, Eric, and really enjoy the conversation.
Thanks for
It's
joining
always a
us again.
pleasure. If anyone actually wants to have some of these models that we're talking about, we have them on our webpage. Just go to SCC 3D Printing, scroll to the bottom, and there'll be a blue button you can click on to take you to our drive, and we have a lot of these models out there. So there's STLs to be had to try these out for yourself and see what you like. And of course, like us on social media and YouTube and everywhere else too. Got to put that plug in. But I appreciate it as always.
Absolutely. We want everybody to join us on whatever social media you are. I think both SCC and us are on a whole bunch of different, we're on LinkedIn and Facebook, and I know SCC has a YouTube channel, as do we. And also, I guess, Instagram, and of course, Twitch and Discord. So you can find us somewhere. There's nowhere to hide anymore.
Yeah,
It's like you
nowhere
can
to
stalk
hide.
us on any platform. All right. Well, thanks again, Eric. We really appreciate it.
No problem. You'll have a
Awesome
good evening.
chatting.
Bye.
See ya.
Bye.